Hey everyone! Today we'll be looking into how to solve problems using the mesh method. So here I have a simple simple question which we can solve now. So find the current in all the branches of the circuit using the mesh method. That's a 10 volt battery and then 10 ohm resistor, 6 ohm resistor, it's a 5 ohm resistor and a 20 volt battery. So we'll be solving this problem step by step. Step 1. Identify the mesh. So what is a mesh? Mesh is the simplest closed path in a circuit. Closed path in a circuit. So in this circuit, we have two mesh, 1 and the 2. So first one will be A, B, C, D, A. So that's the first mesh, A, B, C, D, A. And the second mesh will be C, D, E, F, C. C, D, E, F, C. So these are the two mesh. So A, B, C, D, A and C, D, E, F, C. Now let's look into step 2. Step 2 is marking the mesh current. So in both the mesh, we need to mark the mesh current. The mesh current can be clockwise and anti-clockwise. So here let me do clockwise. One. And this one I'll do anti-clockwise. You can do it the other way around too. Next is step 3. Step 3 is marking the branch current. So let's begin with BC. So in BC, since I1 is clockwise, BC will be B to C. So the current is moving from B to C. That's I1. Next, let's look at CF. So in CF, the I2 is flowing and it's flowing anti-clockwise. It's flowing from F to C. So let's mark here F to C, I2. Next is C to D. In CD, both the currents are passing I1 and I2. If you look at I1 is passing clockwise and I2 is passing anti-clockwise, but they both are going from C to D. So we can mark the current easily from C to D, and the current will be, since both are going together downwards, it will be I1 plus I2. That's simple. Now let's look into step 4. Step 4 is identify the voltage rise and voltage drop. So we need to identify the voltage rise and voltage drop in each of these mesh. So let's start with mesh ABCDA. So ABCDA, this one. Now first is AB. So AB has a voltage source. In voltage source, if we are moving from positive to negative, then voltage drop, and if we are moving from negative to positive, then it's voltage rise. So here AB, we are, since it's A to B, AB in the sense A to B, we are moving from A to B, we are moving from negative to positive. So as I said, negative to positive is voltage rise. So in voltage rise of AB, we can give 10 volt. Now BC, so B to C. In across the resistor, if moving along with the marked current, then voltage drop, and if moving against the marked current, it's voltage rise. I repeat, across the resistor, if moving along with the marked current, then voltage drop. If moving against the marked current, then voltage rise. Here B to C, we are moving with the marked current I1. it's B to C, and the current I1 is also moving from B to C, hence its voltage drop. If you're moving along with the marked current, it's voltage drop. So here B to C is voltage drop. Now voltage is I into R. So here we have the current I1, so it will be I1 into R. Here it'll be 10, so it'll be BC 10 I1, and then CD. So C to D, we are moving along with the current. I1 plus I2 both are moving downwards, so we are moving along with the current. C to D, so it is voltage drop again, and it will be 6 ohm, so it will be 6 I1 plus I2. Next is DA. So D to A, there's nothing here, so you can just leave it blank or give a dash so it's clear. Now, according to Kirchhoff's voltage law, we know that in a closed circuit, the sum of voltage rise is equal to the sum of voltage drop. So here we can write an equation that is sum of V rise. You can write here V rise equal to V drop. So V rise is 10 here, equal to V drop is 10 I1 plus 6 into I1 plus I2. So this is our first equation. We are getting an equation based on Kirchhoff's voltage law. V rise equal to V drop in a closed circuit. So when you simplify this, you will get 16 I1 plus 6 I2 equal to 10. This will be our equation 1. And next we need to find the voltage rise and voltage drop in the second mesh. Here I have the table for the voltage rise and voltage drop in the second mesh, that's C, D, E, F, C. So let's begin from C to D. So if you look here, C to D, we are moving along with I1 and I2, I1 plus I2, we are moving along C to D. So it is voltage drop. You know, if we are moving along with the current direction, it's voltage drop. So in voltage drop, we write 6, right? So we write 6 into I1 plus I2. And now D to E. So if you look here, D to E, there's nothing, so you can just give a dash or just leave it empty. Now E to F. So E to F, it's a voltage source, and in a voltage source, if we are moving from positive to negative, then voltage drop. If moving from negative to positive, then voltage rise. If you see here, moving from E to F, it's mentioned here E to F, so we are moving from negative to positive, so that is voltage rise. So E to S is 20 volt. Next is F to C. If you see here, F to C, we are moving along with the current direction. F to C, that's I2, we are moving along with I2. So the voltage will be, it's 5 ohm there, so the voltage will be 5 I2. So from this also we can write an equation, voltage rise equal to voltage drop. We'll be able to write an equation, and yeah, so voltage rise here is 20 equal to voltage drop is 6 I1 plus I2 plus 5 I2. So when you simplify this, you will get the second equation, that is 6i1 plus 11i2 equal to 20. That's equation number 2. So we got two equations. Here was equation 1, that's from mesh 1, the first mesh, and we have an equation 2, that's from the second mesh. So it's 16i1 plus 6i2 equal to 10, and 6i1 plus 11i2 equal to 20. These are the two simultaneous equations. So if you solve this equation, you'll get the answer for i1 and i2. So you can solve it using the calculator. That'll be easy. Here I have my calculator. So let's do this. So now it's in simultaneous equations mode, and first is 16 equal to 6 equal to 10, and then the second equation is 6 equal to 11 equal to 20. So this is the first value, that's i1's value, that is minus 0.07, and then this i2, that's 1.86. so those are the two i1 and i2 values. So now we got the value of i1 and i2. So it's really easy to solve and find the branch current, because in B to C it's I1, so you can directly write minus 0.07 ampere. Then C to D it's I1 plus I2, so you just have to add these two. In C to F it is I2, so you could just give the current of I2. Yeah, so this makes it really easy to find, and that's how you do it. Now this same question can be done directly without doing all the step 1, step 2 and step 4. You can directly do it using matrix methods. So in the matrix you can see I've just mentioned x, y, y, z, I1, I2 and b1, b2. So the x value is sum of resistance in mesh 1. So if you see, this one is sum of resistance in first mesh. So this is the first mesh, that's A, B, C, D, A. So the sum of resistance here will be 10 plus 6. So you can do it 16. Now y is the resistance common to first mesh and the second mesh. So here the resistance that's common to the first mesh and the second mesh is 6. So y will be 6. And in this you have to look into another thing, that if both the current, that's I1 and I2, are flowing in the same direction in this branch, C to D, in this branch, if I1 and I2 are flowing the same direction, if they are in the opposite direction, it will be minus 6. Since in this question they are flowing in the same direction, it's I1 plus I2, so it is positive, and positive 6. Y, both are y, so here also it's 6, it's obvious. And then is ether, the sum of all resistance in loop, the second loop, at C, D, E, F, C. So here there's a 5 and 6, so that's 11. Now I1, I2 is what we have to find. I mean, this is I1, sorry. I2. Now voltage, if you look here, voltage is found by where the current starts from. So in this, if you see, the current starts from positive. It goes like this. I'm drawing the same clockwise thing here, I1. It's flowing from positive. It's starting to flow from positive of the battery. So that's positive 10. In here also, if you extend this and look here, it starts to flow from positive, and here it's 20, so it's flowing from positive. Here also it's flowing from positive. You see, it flows from positive. So here it's positive 20. Now this is a matrix. You can directly type it into the calculator and you get the same answer. I1 equal to minus 0.07 ampere, I2 equal to 1.86 ampere. So it's much more easier. Instead of doing step 1, step 2, step 3 and step 4, you can directly find the answer. Now I have an example question of that here. So it's a similar question, same method, but a little bit different because V2 is not in mesh 2. It's basically common to mesh 1 and mesh 2 here. You can just pause the video and read the steps and go through this problem as well. You can try to do this problem on your own. I think it'll be helpful. This is the main part. This is the key to identify voltage drop and voltage rise. It's very important. If you understand this, then this mesh method is really easy for you to do. Now this is the second method. That's the matrix one, directly doing it. So here also I've mentioned with x, y, y, z, and this one is alternated based to this question. You can see this. Pause the video and read through the notes. It will make it easy for you to understand. Now, in this, I forgot to mention, in this, the direction of current, I've marked it both clockwise. So when the direction of current both is clockwise, it's I1 minus I2. The answer is going to be same. That's not gonna be a difference in the answer. It's still going to be the same. But here, when you mention it, it'll be I1 minus I2. So that's what I wanted to show. That's all for today. So you have learned how to do problems in mesh method. I believe it's easier to do it, and you understood everything clearly. Thank you. Aksha signing off.